Okay. I'm Stephen Edberg. I'm an astronomer at Jet Propulsion Laboratory, part of the California Institute of Technology, and I'm involved both in outreach and of various types, whether it's websites, blogging, or any of our teaching. And I also, as the need arises, do spaceflight, both planning and operations, both developing and flying spacecraft. So it's a varied career.
That's nice. Thank you very much. We're here to talk about the current eclipse that is happening in this part of the world, out west, and it is a annular solar eclipse. So, as an astronomer, as part of your interests, can you tell us a little bit about what it is and what is unique about it?
Okay. Well, an annular eclipse and total eclipses are what are called central eclipses, because for some path across Earth, you can get in that path and see that the moon is centered on the sun. The big question is it centered and appearing larger than the whole disk of the sun, or is it centered and appearing smaller? If it's larger, we call it a total solar eclipse. If it's smaller, it's an annular solar eclipse. Annulus being the kind of the source of that word and meaning a ring. And in this case, we have an annular eclipse. The moon is going to be a little smaller than the sun, and so the people within the path are going to see a ring of sunlight for about 4 minutes or a little longer, depending where on the path they are, both sideways from the center and whether they're closer to local noon on Earth, which is actually occurring out in the Pacific Ocean, or closer to sunset, which in this case will be in Texas. The interesting thing about an annular eclipse, though, is that it's what I could also quite correctly call a central partial eclipse. Partial eclipse means that the sun is not centered on the disk of the sun. I'm sorry, that the moon is not centered on the disk of the sun. And so you see typically a crescent or maybe just a nibble, a bite out of the disk of the sun. Partial eclipse. Interesting, but not real, not something that people get real excited about. With this particular eclipse, a lot of the western part of the country will see a significant fraction of the sun covered, and actually a pretty nice crescent at maximum eclipse, whatever they see, unless it happens to be centered. The important thing to know, though, is that for this eclipse, a solar filter, something like this, is really required for the whole period of the eclipse. You do not want to risk damaging your eyes and seeing the sun, looking at the sun without a filter like this, and this is not regular sunglasses. If you are risking essentially burning your retina, and at a minimum you might lose the ability to read. You lose the part that is most important for our vision, because you're staring at an eclipse. So safety is paramount in this. And there are sources for filters like this. Here's another example. You can also just go to a welding supply store and get number 14 welding glass, and it's surprisingly inexpensive, and it will be safe. So I just can't emphasize enough that even though it's an annular eclipse, it's a partial eclipse for everyone, and observing it without proper filtration is very, very dangerous.
So our next question is about the science. So historically, people have been observing eclipses with and without, unfortunately, the kinds of materials we can use now to keep our eyes safe. But they have seen solar eclipses for back in historical times,
Thousands of years.
So how have scientists learned? What have scientists learned from solar eclipses, partial or total?
Well, a lot about the sun. I mean, let's just start with total. And total solar eclipse reveals a whole layer of the sun that is otherwise not visible. It's called the corona. when we look at the sun during the day with proper filtration, we see what's called the photosphere. It's a layer that's about 6,000 degrees Kelvin, or about 10,000 Fahrenheit, and that part of that heat is what's generating the light that we see. There is a layer above that that was not discovered until people started paying attention to eclipses, and that's called the chromosphere. It's a layer that's about 10,000 Kelvin, or about 18 to 20,000 Fahrenheit, and is only visible briefly. It's a very thin layer, maybe 18,000 kilometers or 10,000 miles thick, though again all these numbers are a little bit soft. And then above that, what was completely invisible without a total eclipse and without modern instrumentation was the corona. And one of the ongoing mysteries, as long as we've been studying the sun, has been, why is the corona at temperatures of 1,000,000 degrees or more, 2 million Fahrenheit, while the lower layers are cooler? And that is still intensely being studied. So that's what total eclipses tell us. Even when you intentionally are going to annular eclipses or even partial eclipses, especially annulars, you can observe what are called Bailey's beads. Some of the processes that go on in the sun we still try and understand. Has the sun been changing its size over the centuries? Well, it turns out by looking for these beads, it's where sunlight, photospheric light, the white light layer, gets through valleys on the moon between mountains. You can actually define very well where the path of the eclipse is, and from knowing where the path is, both north and south sides of it, you can then determine the actual size of the sun, because we know its motion well enough, or Earth's motion around the sun and the moon's motion around Earth well enough, to be able to determine the physical size of the sun. And by having eclipses over several centuries, and the earliest I've known this to be studied goes back to 1716, I think it was. Edmund Halley was involved in it. And by going back over, as I say, several centuries, we can see if the sun has been changing its size. And it's a very hard measurement. I haven't seen the latest publication on it, so I can't relay the results, but it is something that, again, is something that is done during eclipses. So even the timing of just the contacts with the beginning and end of a partial eclipse, so when is that first nibble visible, when is the last little nibble visible, can tell us something about the orbital motions of, again, all three bodies: Earth around the sun, Moon around Earth. And that is helpful. Now, admittedly, spacecraft have done a lot to reduce our need for that, but it never hurts to do a check, to look in different ways. That's part of what we do with science.
Well, that leads us to my last question, which is, why are you personally here to see the solar eclipse, and why would it be a good thing for other people to get out, kids, teachers, adults, to see the solar eclipse? So.
Well, I encourage everyone to see natural phenomena. And with something like this, it's going to be, with 80 or 85% of the sun's diameter covered during this eclipse, it's going to be noticeably darker than your typical late afternoon at the same time. And so just a chance to notice that and see this pretty narrow crescent sun is something that eclipses don't come to us that often. You just take advantage of it. My personal interest is kind of based on past experience with two separate annular eclipses, one in 1992, one in 1994, and conveniently this one is coming close and making it easy for me to combine what I was interested in for those individually into one event. And so I'm heading off to Texas. Weather permitting, I'll be looking to see if I'll be studying Bailey's beads, and I want to see what the atmospheric effects of a very low sun is on those Baily's beads. The beads, as I say, are very bright little patches of photosphere coming through. And I'm anticipating that they're going to be twinkling like stars, especially very low on the horizon. And so I've got video planned and still photography, and I'm going to just see what happens. And again, is there science there? Maybe, maybe not. But I'm just intrigued with the natural phenomenon, and it's worth the effort for me to go ahead and do that. Actually, what are called syzygies, alignments of three objects in the sky in this period. The first one in the set is this annular eclipse of the sun. The second is actually going to be a lunar eclipse about 2 weeks later, which is only partial, and so is not quite as perfect an alignment, but still it's part of the package. And then just 2 days after that, we have the syzygy that involves not Sun, Earth, Moon, or Sun, Moon, Earth, but it's Sun, Venus, Earth. And when we look at the transit, in this case, we're going to be seeing Venus moving across the face of the Sun. Well, that's exactly what we're seeing with the Moon. The Moon is not big enough to cover the Sun, so it, in fact, is transiting the disk, only we call it a solar eclipse. What's actually interesting in all of this is that, in fact, the annular eclipse is better called a transit. A total eclipse is better called an occultation, because a larger object is covering a smaller object in terms of angular size, not physical size. And of course, the transit of Venus is a very small object silhouetted against a much larger object. The only real eclipse in this whole period of three events is the lunar eclipse, where the Moon is entering the shadow of Earth for a few hours. And so we've got a lot of misnomers here, and a lot of fun science and natural phenomena to observe.